Hey guys, so in the last classes we have done with the concept of the RSTP protocol, right? RSTP we can call it in the IEEE standard, in the Cisco body we can call it the RPVST. Guys, anyone has a questions in the PVST protocol and the CST one, and the like how the spanning tree states, right? And the backbone fast, uplink fast, and port fast. Anyone has a questions? Anyone? Shall I move to the next part?
Hello, can you give me a brief explanation on this backbone and uplink first?
Or, if this is the blocking per state, right? And what happened if this link goes down? Normally, if this link goes down, what happened? Normally, this interface will take after the blocking state. What are the next step? We have listening, and after listening, we have a learning state, right? So total, how many spin I'm going to spend in the 15 second? In the listening state, 15 second, learning 15, and then forwarding. So if this link goes down, right, the root port, if the root port goes down, how long it will take to make this port into the forwarding state? Blocking, the listening, and then learning, 30 seconds. So till 30 seconds, this user cannot communicate with this person. So in that case, what happened? I'm going to enable the uplink fast feature out there. After enabling the uplink fast feature, what happened? This interface, if the RP port goes down, this interface immediately move in the forwarding state. Just in a 1 second. That was a uplink fast. After enabling the uplink fast, what happened? Normally the cost will increase to the 3000 and the priority will be increased to the 49152 49151. And then after that, the VLAN number. Normally, you're going to apply this feature on the access layer switches, not the distribution layer. Now, in a backbone first, what happened? Take example, right now this link is working fine. So these are my blocking ports. Take example, if this link goes down, then switch 2 will behave like a, hey, I'm a root bridge, because switch 2 lose the connectivity of the root bridge, right? Switch 2 lose the connectivity with the root bridge. So switch 2 will assume that, hey, I'm the new root bridge, and he will inform to the switch 3, hey, I'm the new root bridge. But switch 3 already have an idea about the root bridge from this interface, right? So what switch 3 will do, they will put this information, right, on the 0/2 interface, right? Switch 3 is receiving the BPD from the switch 2. So what happened? The switch 3 will never consider this guy till 20 seconds. That is the maximum time. Once the maximum time will be, expired, then this port will move in the listening and learning. So 15 second, 15 second, and total 20 second, 50 second over there. But after enabling the backbone fast feature, what happened? Normally, I'm going to skip this guy, maximum time. How? When the switch 2 will inform to the switch 3, hey, I'm the new root bridge, switch 3 will immediately ask to the switch 1, hey, are you there, by sending the root link query. If the switch 1 will give the reply, yes, I'm there, what happened? Switch 3 will not going to wait for the 20 seconds. It will immediately put this interface into the listening state, then learning. So total 30 seconds will take after enabling the backup fast. Yeah.
Fine.
Okay. Now, guys, you have a 5 minutes. I'm a little bit hungry right now. You guys have 3 minutes max to max. Tell me what is the problem with the RPVST protocol? Think about it. What is the problem with the RPVST? See, we have an issue with the PVST. PVST is a slow protocol. Then we have introduced the faster. But what is the issue with this guy?
Scope update.
Lena RSTP IEEE standard.
No, other vendors can't use RPVST, right?
Any other?
No load balancing on or in RSTP.
Anything else?
It should run all VLAN.
You know, now think about it according to the topology. Try to understand if you have a switch 1, right? and switch 2. And here we have a, understand this part now. Switch 1, switch 2. Just last one, right? Now, this is the root bridge right now. Okay, leave it right now. I'll make this guy like this. Take a screenshot. Copy and paste. And take a screenshot, copy and paste. So this is the root bridge right now, right? And this is non-root bridge. So in this case, what happened? This will be the DP port, this will be the DP port, this will be the RP port, this will be the blocking, right? Okay. How many VLANs we have? On the switch 1, we have a VLAN number 10 to 100. Like this. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. How many millions they have? Switch 1? 100. 10 to 100. 10, total 10 millions over there. This is also 10 millions. Tell me how many logical topology you can make from there. How many logical topology you can make from there?
Only 2.
Either this one, I can make this guy, hey, you are the root bridge, right? So this interface will be blocking. And either I can make this guy the root bridge like this. That's it, right? We just have this or this two option only.
Yes.
How many spanning tree algorithm we have going to run over there? On a switch 1. If you are running with the RPVST or PBST.
10.
Right? Depend on the VLAN number. Now tell me, is it a feasible solution that you are going to run the you're going to run the 10 instance or 10 spanning tree instance for the 10 VLAN, but you just have a 2 logical topology. दो ही बना सकते हो, इससे ज्यादा तो कोई ऑप्शन ही नहीं है ना. You don't have any other option, right? या तो 10, 20, 30, 40, 50. This is the root bridge. 60, 70, 80, 90, 100. This is the root bridge. इसके अलावा that's perfect, right? You can do the load balancing. I'm not denying it. Listen to me. You can do the load balancing. I'm never denying it. But think about it according to the CPU. Think about it according to the performance. Think about it according to the how many BPD you are sending. Think about it according to the memory consumption. Think about it according to the bandwidth wastage. What I'm telling you, if you're going to run with the PVST protocol or RPVST protocol, it's good, right? You can do the load balancing. But take example, if this switch does not have a much CPU, if this switch does not have a much CPU, then You know, if you don't have a much process on the switches, you cannot do the telnet access of the switch. And even the performance of the switch will be degraded. They will perform, they will give the pretty slow response. And being a good network engineer, do you know what you want? Being a good network engineer, you are always going to save the resources. But is it possible to save the resources in the RPVST and PVST protocol? No. We have, see, if you have a only two VLANs, 10 and 20, and 10 and 20, it's good, right? I'll make this guy's a root beer for the 10 and this guy's a 20. Perfect. It's good. But if you have a number of VLANs, right? And if you have a small topology, listen to me. If you have a huge VLAN, but small topology, in this case, is it possible? Of course not. This is not a good solution. Never ever recommendation to the good solution. So to avoid this problem, what we have introduced, we introduced the concept of the MST protocol. Multiple spanning tree protocol. It is the combination of the CST protocol and RPVST. It means that if you just enable the command spanning tree mode MST, that's it. By default, it behaves like a CST protocol. It means that for all VLAN, doesn't matter how many VLANs you have, for all VLAN, we have a single spanning tree instance. Amazing. But the good thing about this guy will give you faster convergence like RSTP does. But the thing is that I can see the huge amount of wastage of memory, CPU, wastage of bandwidth, and resources as well as. Can you see the beauty of MST protocol? If you just put this command, right? I'm not do anything. Just put the single command line spanning in mode MST. It behaves like a CST protocol. It means that if you have a understand this part now. How many VLANs you have? 10 VLANs, right? 10, 20, 30, 40, 50, 60, 90. Of course, you will be the root bridge, right? Of course, you will be the root bridge. Of course, you will be the root bridge, and you will be the non-root. You cannot do the load balancing, but you will have a faster convergence. At the same time, I can save the huge amount of memory and bandwidth, right? If you want a load balancing, if you want a load balancing, then you can do one thing. It allow you, if you want load balancing, it allow you to map, listen to me, the VLAN with particular instance. For example, I say that VLAN number 10, 20, 30, 40, 50 will be part of the instance number 1. VLAN number 60, 70, 80, 90, 100 will be part of the instance number 2. And whatever the remaining VLAN is in the sense of what? 1 to 9, right? Then 11 to 19, like this, then 21 to 29, then 31 to the 39, then 41 to the 49, then 51 to the 59, then 61 to the 69, then 71 to the 79, then 81 to the 89, then 91 to the 99, and 101 to the 4094. All this VLAN will be a member of the instance number 0. See the POP, guys. You just need to do one thing. You just need to map the VLAN if you want to do the load balancing. How do I map it? I call it, hey, listen, you are the part of the instance number 1. You are the part of the instance number 2. And whatever the remaining VLANs we have, all they are part of the instance number 0. And this instance number 0 is by default created. You don't need to create this thing. It's by default created. After enabling this command, right? After enabling aspiring tree mode MST protocol, this will be automatically created. You don't need to create this thing. And now after what I can do over there, now listen, you are the root bridge for the instance number 1. And you are the root bridge for the instance number 2. So whatever the VLANs in the instance number 1, 10, 20, 30, 40, switch 1 will be a root bridge for all this VLAN. And switch 2 will be a root bridge for all this VLAN, such as 20, 80, 90, 100. Now tell me one thing. I can achieve the load balancing at the same time. I can save the memory. I can save the bandwidth. I'm not going to send the 10 BPD now. How many BPD I'm going to send per instance basis? Instance 1 BPD, instance number 2 BPD. That's it. Or of course 0, of course, right? How many algorithm I'm going to run? 10? No, I just need to run the 2 algorithm. One for this guy and one for this guy. So MST protocol is the combination of everything, CST and RPVST. If you want a CST, leave it. If you want a RPVST, map it. All good, guys. Anyone has a questions? Till this point. All clear? Your BPD will be same. Nothing is different. The same BPD. I'm just going to add a one extra header over there. And this extra header is called as a MST extension. In this MST extension, I'm going to put this information. Normally, I'm not going to send this guy, the instance of this information like this, instance of one like this, or instance of 2 like this. I'm going to apply the MD5 algorithm over there, right? And I will get some hash value. I'm going to run the MD5 algorithm of this guy, and I will get some hash value, right? And I'm going to share this hash value in this MST extension. If the neighbor switch is right, if both the switches have a same MD5 digest value, it means they belongs to the same region, and we can call it MST intra region. If both the switches have different MD as value, then it belongs to and we can call it MST inter region. If you have a look, चाहूंगा मैं तुम्हें MD5 has a CCI, right? Generator has value of this guy. You see that? Copy. This is the has value. They upgrade their website. Previously, it was not like this. And now I'm just going to change, right? If you see, I'm just going to change the CC E a small letter and generator the has. Copy. What is the has? Both has are different. Can you see that? The has value of this string is different. The has value of this string is different. So if any change will happen, right? It means that both are in different region. Any mapping. So it means that this mapping that I'm going to create here, guys, this mapping that I've created, this mapping, instance number 1, VLAN number 10, 20, 40, 40, and this mapping I've created. This has to be same, right, on the both the device, switch 1 and switch 2. Same thing, switch 1 and switch 2. If you want to make these two guys in the same region, if the mapping will be different, for example, on this guy I have configured this mapping, on switch 2 I have configured the 51 as well. Then digest value will be different. So they have belong to the own region, they guys belong to the own region. Have a look. It's a very easy one. It's not a hard. So let me open my GNS3. Uh-oh. मुझे कर दो मैं इसको I'll do surveys. Two switches is enough to check all the behavior, right? Switch. Switch 1, switch 2. अरे बाबा, अरे बाबा. Oh, good. Switch one has came up and switch to on. All great. So what are the first thing? I'll just create some VLAN, right? Enable configure hosting system. Done. And what we call over there, I'll see the VLAN number 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The same VLAN I'm going to create on a switch to SMS. Done. Done. If you capture this link right now, by default spine tree is enabled, and I'll just show you the one BPDU capture, okay, of the RST protocol, so that we can correlate, right, whatever the things that we are going to add it, not we are it, or whatever things that switches is being added. This is the RST BPDU, right? I'm not talking about the PBST because the MSTP, right, is behave like a, not behave like a, is like, you know, the working of the MSTP in the background is behave like RST protocol. Perfect. And now let's do one thing. Let's come back to the switch one. I'll make the interface as a one because I need to make this interface as a part of the ini. Sorry, I need to make this VLAN is a part of the ini interfaces. So better to create the interface trunk, right? Because trunk will carry all the VLAN information, right? You can make a access port as well as other, but I cannot do that access right now because, you know, I have to add the multiple routers. So better to add this VLAN into the trunk. Switch port. Switch port trunk encapsulation.1 to switch port mode trunk. All done. So do show interface terminal. Hope we have a terminal. All good. Perfect. And you can see that all the VLANs is allowed 10, 20, 30, 40, 50, 60, 90, 80, right? And the gig 0/0. Right now, which protocol I'm enable over the do so spine tree? The default protocol is enabled over there is RSTP, RPUST, right? Rapid PST mode. I'm going to change this mode. I'll say that, hey, listen, now you're going to enable with the spine tree mode and same thing I'm going to configure on the switch 2 as well as spine tree mode MST. And they are backward compatible, don't worry. And if you see show spine tree, first of all, what happened? The mode had changed, and which one I'm going to run? MSTP. MSTP is a Cisco provided protocol, right? Not MSTP. MISTP is a Cisco. MSTP is IEEE. Right. Yeah. This is a root bridge. Just cross check it. The MSTP, I think so. It's a IEEE. Just cross check it on the Google. And if you see that, wait for some more time. Meanwhile, I'll show you the spanning tree MST configuration. Did I configure any kind of instance over there? No. So by default, what happened? All the VLAN is mapped with the instance number 0. Did I configure this instance 0? No. What I told you that after just putting this command, right? After putting this command, spine tree mode MST, this guy is behave like a CST protocol. So now this behave like a CST, right? Common spine tree. With every VLAN, common spine tree protocol. Do I have any name? Nothing, by default empty. Revision number is 0 by default. This revision number has a different concept. In a VTP revision number, if you remember that, it was a dynamic behavior. In a VTP, it was a dynamic behavior. Dynamic behavior in the sense of what? If the network engineer is modified, if the network engineer modify the any VLAN database table, right? like creating the VLAN, adding the VLAN, removing the VLAN, changing the name of the VLAN, automatically what happened, revision number will be incremented by 1. But in the case of MSTP protocol, the revision number is not incremented by 1 by default. You have to manually increment 1. Concept is same. Both is going to indicate that this is the more updated information. But here in the MST protocol, what happened? This revision number you have to increase. For example, I changed the something. I in the instance number previously instance number 1, VLAN number 10, 20, 30 was there, right? Network engineer came over there and they add the 40 over there. So what they will do, they will whatever the revision number previously was there, 0. So they will just make a revision number 1 now. So that other network engineer can understand, okay, something has changed. Something has changed in my network. After that, some other engineer is coming and they will make a 50 over there. So what happened? They will make a 1 plus 1, now 2. After some time, one guy is coming and they will remove the 30 over there. So what happened? 1 or 2 plus 1, 3. But you have to manually implement this revision number so that other person can understand, okay, something had changed in my network, something has modified. All clear? So this revision number is totally different from the BTP revision number. Name, you can define any name of them. But all this parameter, name, revision number, or instance mapping has to be seen on the both the device. Then it behave like a same reason. By default, if you see, it's behave like a CST protocol. So what I can do, first of all, I just need to move in the box, that box called as a spanning tree MST configuration. You need to go in this box and here you need to define the name. If this name is optional and division number, I will call as a 1. This name is optional, it's up to you. You can define any name. It's totally up to you. This is just a logical name. So we can identify, okay, this reason, this particular domain is belong to the CCI to easily understand. Otherwise, these are the optional command. The mandate command is what? The mandate command, this part, instance number 1, I can call it VLAN number 10, 20, 30, 40, and 50. Instance number 2, I can call it 60, 70, 80, 90, 100. And now I need to copy this command configuration and paste it on a switch 1 and switch 2. Because you have to put the same configuration on switch 1 and switch 2 as well. So that both will calculate the MD5 digest value. And if the MD5 digest value will be same, then it behave like a same reason. Now, if you see on grid, so span free MST configuration, can you see that the VLAN instance number 1, we have a 10, 20, 30, 40 according to this configuration, and 2 we have a this one, and rest of the all the rest of the part will be 0. The name that I have configured CCI and division number. So now if you show span free MST configuration digest value, if you see the digest value of this guy, and if you see the digest value of this guy as well as span free, so span free MST configuration digest. If you see the digest value of this person, right, on the switch 2, right, and if you see the switch 1 as well as, both are same, right? So if the digest value will be same, then it behave like a same reason. It behave like a same reason. Intra MST. And now if you have a look the BPD, right? If you see, still the same thing is there. Proposal agreement, same process is happening. Nothing is different over there. Only the thing is that we have a BPD version 3 now. In the RSTP protocol, we had a 2. In the MST, we have a 3 now. And if you see this MST extension I was talking about, this guy. If you compare with the, this part, if you compare with this part, right? Till this point is same, right? If you see, till this point is same. Here is the changes happening. MST extension, extra information. The MST config ID or format selector is always set to the 0 in the Cisco device. Always set to the 0. MST configure name that have defined CCI. This is the reserved value, right? This is the reserved value. Okay. Config always set to the 0. Name will be, I don't know the another vendor. Maybe another vendor some value will be there. But in a Cisco it's set with the 0 under MST configure name CCI. Maybe in the some, the some different technology, it could be any value, right? But as per my understanding and according to the docs and books, this always set to 0. This is a reserved value. Okay. I read somewhere, I don't know where I read it. This is the use of something other purpose, but normally you will find this guys as 0. MST config name is CCI, revision number is 1, and these are the digest value I'm sending. Am I sending the mapping information? This mapping that I've created over there? No, I'm just exchanging the digest because it's not possible to exchange all the mapping information. Can you see that if you have 100 mapping, then is it possible to see the all 100 mapping information? No. What is the use of digest value? What digest value? The meaning of digest means what? They will compress the information, and that compression information I'm going to send on the link. So if you have thousands of the VLAN, is it possible to send thousands of VLAN? So what they will do, they will compress the detailed information, the sort information that is called as a digest value. And now if you see this guy switch one, I'm going to make this guy spine tree move. Okay. Hey, listen. Spine tree MST one. I'm going to make it a root primary, or we can say the priority will be 0. I'll make this guy for the MST number 1, priority will be 0. And I'm going to make this guy. Hey, you are the spine tree MST number. Root priority will be 0. So for the instance number 1, right? What I did over there, this configuration of the switch 1 and switch 2 as well, right? And after that, what I did, I said the switch for the switch 1, spanning tree MST1, priority will be 0. Switch 2, spanning tree MST number 2, priority will be 0. It means that switch 1 is the root bridge for this VLAN. Switch 2 is the root bridge for this VLAN. How many spanning tree instances we are in? Just 3, right? 0, 1, 2, not the 10. And now if you have a look at the thing, one more thing is over there, like if you remember that in normally the bridge ID, right, is a 8-byte field. In the 8-byte field, what happened? We have a MAC 6-byte, then we have a priority. In the priority 3276, it is by default, and then after that we have a VLAN number, right? In normal RSTP and PVST protocol. But if I talk about the MST one, we have a same one, bridge ID, right? And we have something called MAC address. Same we have priority. But now the priority is the 32768. But here I'm not going to add the VLAN number. Here I'm going to add the instance number. So if you switch one, right? MST number 1. So what will the priority of this guy? 32769, right? If you see, so it's fine tree. What is the priority? One minute. Okay, this is the MST0, right? This is for the MST0. Okay. If you switch MST number 1, this should be a root bridge, right? And if you see, I've configured the instance number 1. This should be a root bridge, MST1. And the priority will be 1. Because I changed the priority is 0, right? So I made the 0. 0 means what? 0 plus 1. So 1, right? And this is the root bridge for the MST number 1. And in the MST number 1, how many VLANs we have? Same thing if you go back to the system now. So it's finding 0 plus 2, right? You see the priority 2, and this is the root bridge. And for me, I have every ports as a D port. Because I'm the root bridge for the MST number 2. For the MST number 1, I have blocking. Because I'm not a root bridge, right? So of course I will have a unblocking. All clear? Now, if you see one more thing over there, so it's binary, MST, MST number 0, right? In the MST number 0, VLAN map is this amount of VLAN is mapped, right? This is the bridge ID, the address of the MAC address, then priority is the 32768 by default. And I cannot add the for the MST 0 means at 32768 plus 0, it will still become the 32768. And if you see over there one thing over there, right? My hello time is still same, the forward delay is still same, and max is still same. Why just forward the backward compatibility? That's it. And this switch is a CIST. It means that this is the one root bridge for the entire region. This is the root bridge for the entire. If you have a take example, if you have a multiple region, region number 1, take example, this is the region number 1, and this is the region number 2, right? And in the region number 2, we have switch 3 and switch 4 as well as, right? So this is the how, like this connectivity we have, right? Take example. Okay, so we have a region number. This is the CCI, I can define it, and this is the CCNP region number, right? So in the see, try to understand. We have two different region, right? This is the CCI region. This is the CCNP region. Understood? So for this reason, he is the root bridge, right? Take example. For this reason, he is the root bridge, right? It is something like that. Understand like this way. We have a Karnataka, Chennai, sorry, Karnataka, Tamil Nadu, Delhi, Mumbai, Bihar, Jharkhand. You know, different states we have, right? We have a different state. So each state has a one chief minister, right? That is going to CM. We can call it CM, chief minister, that is going to manage the state. But at the same time, what happened? To run the entire country, we need a one leader, right? And that leader is called as a PM, Prime Minister. Same thing. This is the one reason. This is the one state. So this is the guy that is the root bridge for this state. This is the guy is the root bridge for this state. But for all this reason, who will be the leader? That is called as a CIST. You can make anyone. So any of the switch will become the CIST. Those have a lower MAC address and priority. Simple. Those have a lower bridge ID. Overall, switch 1, switch 2, switch 3, switch 4. They will calculate who has a lower bridge ID. So I'm assuming this guy has a lower bridge ID. So this guy will become the CIST. So this is the guy that is going to manage the entire region. Entire region is what? CCI region and CCNP region. He's the Prime Minister. That is the meaning of CIST over there. So MST0 is the CIST. And if you see, for the MST number 1, I'm the root bridge. And my priority is 1 because I have configured the, the 0. And this is the MST number VLAN map is the 1020/2040 and MST number 2, right? 60/2080. So switch 1 is saying that, hey, I'm not a root bridge, right? Who is the root bridge for the MST number 2? This is the root bridge. And who is this guy? That is person. How many hops away this guy? So switch one is saying that, hey, switch one is saying, I'm present on switch one. Switch one is saying that, hey, this guy, this is the root, that is this guy, this address, is the one hop away. How do I know that? 19. Because when this person will send the BPDU, in this BPDU, what happened? They will send the hop will be 20. So once this guy will receive it, what they will do? They will decrement by 1. So it will receive the 19 over there, right? It is sending with the 20, it will receive it and decrement the 1. Like a TTL value, the layer 3. Once they will receive it and they will decrement. So you're saying that, hey, switch 1 is a 1 hop away. 90 means what? 20 minus 90, 1 hop away. These are the things that we have in the MST. That's enough information according to the CCNP, right? And we have something called, so this is not enough one. Like this is the more detailed information also present. So once you come to the CCI now, then you have a MST inter-region communication as well as that has a little bit more things over there. But yes, this is the enough one. If you have a if you look at your book as well as this is the enough information. Even in your book, that's information is not there much information. I think so 2 and 3 pages are there, if I'm not wrong, if you have a look. Okay, that's that. But yeah, normally what happened in an interview, right? MST is nobody asking, right? Very rarely they are asking MST questions. And normally, like the MST is deploying in the data center part.
So MST will be used only in data centers, right?
It's not like that. Of course, if you have a demand, you can use in the corporate or enterprise network as well as. I just say that, like
Okay.
many times I have like seen that in the data center network.
Okay.
So MST is spanning MST protocol. Read this line. PVST Plus seems more attractive to the meet the goal of because it allows the different VLAN to have a different topology so that each uplink can be forwarding. But the think of the consequence as the number of VLAN increase, so does the number of independent spanning tree instance. Number of VLAN increase, so number of independent spanning tree instance. Each instance uses some amount of the switch CPU and memory resources. The more instances that are used, fewer CPU resources will be available for the switching, right? And that's not a good idea. So they will came with the concept of the MST, and what MST is going to do, it map the VLAN. What this guy is mapping the one more VLAN to the single spine instance. Yeah, MST is a build of the concept like this. So you have these are the like you can define the name up to 32 characters. This is the revision number, and this is the MST VLAN mapping that you can map the range of the VLAN. So if the two switches have the same set of attributes, they belong to the same MST region. If they're not, they belong to the, of course, that I told you, the MD5. MST BPDU contains the configuration attributes so that the switch receiving the BPDU can compare the against their local MST configuration. If attribute will be matches, the spine tree instance within the MST can be said as a part of the same region, right? If not, if the configuration will not match, if this configuration will not match, so they belong to the different region. And between the region, what happened? Is behave like a traditional spanning tree protocol. It means that you cannot do the load balancing, right, between the region. Traditional MST. Traditional MST means what? CST I'm talking about. That's it. So inside a region, the actual MST exists along in the IST. The Cisco support the 16 MST in each region, right? You can have only 16 MST, right? That's it. Only MST, that's it. The MD code is like, that we have seen the MST extension, we can call it. And here we have a configuration. So the configuration division number gives this region a call. So the configuration division gives you the means of tracking change to the MST region configuration. Each time you make changes to the configuration, you should increase number by 1. So by default, it's not you have to change it. It's just going to track the changing MST configuration. And I'm done. This is all. So there's just 3 and 4 which is the book start information is giving you. So the most of the things that MST comes in the the CCI MST into reason communication. Anyone has questions?
Can you open that notepad file once? So for suppose if I want to create one more VLAN, let it
just-
do
You just
VLAN
add
one.
it on. You just
Oh,
add it
okay.
on. You just need to tell which instance you are going to add. Instance 1 or 2. Add it
Okay.
instance 2. Maybe the 110. So this configuration you have to modify on every switches as well as switch 1, switch 2.
Need to
Otherwise,
mode. Okay. I need to enter all 10, 20, 30, or just 110 is
you
enough.
just need to add one on.
Okay. Okay.
Like you are seeing like this, like for example, I'm going to create the VLAN number 1110, and you need to what we call it. 1 minute. The name is this guy. It's 91 and division number. Copy or instance number 1. I think so. If I want to, we have any option 110. I think they will remove it. So it's 90 MST configuration. No, you just need to put the 1. That's it.
Okay. Fine. Clear.
Okay, so something I want to show you about the something else. It's fine, repeatable. Okay, this two switch is enough one to understand the concept, right? System, system. Take example. Take example. This is the right now 0 100 is the MAC address. This is the 0 200 is the MAC address, right? What happened? This is the root bridge. And if attacker is coming over there, and what attacker will do? This is the attacker, and what attacker will do? It will send the superior BPD. Superior BPD in the sense of what? It will send the priority will be 0. Then what happened? What switch one will do? This is the attacker, right? What switch one will do? Switch one will accept this BPD and it will change their own mode. It is the non-root bridge and this guy with the root bridge. So the for entire whatever the switches we have between, like whatever the switches we have behind this guy, whatever the switches we have behind this guy, whatever the switches we have, the entire network will be change. Converge, right? Of course, right? And after that, again he's sending, hey, inferior BPD. Inferior means what? Not a best BPD. What happened? This guy said, hey, now I'm the root bridge. After that, he's sending superior BPD. He said, hey, now I'm the non-root bridge because you are sending superior. After some time, he's saying the inferior one. It means that you are the root bridge. So attacker can change your network, right, if they want. So to avoid this problem, what we can do over there, I'm going to apply the root guard feature. And what root guard feature is going to do? Can you see the guard? Guard means what? I'm going to protect my root bridge from the superior BPDU. It's not an example of the only attacker. Even if you have a normal switches, right? And if normal switches has a lower, take example, lower MAC address, A or 0. So what happened? They can inform to this person, hey, mine is a lower MAC address. I would like to become the root bridge. So entire network will be changed. What is the root bridge? Root bridge is the centralized point, right? Root bridge is the centralized point, and from there everything is happening. So centralized point always should be fixed. It's not like a variable mode, right? It always has to be fixed. So if they are keep changing the centralized location, what happened? You are changing your network. So to avoid this problem, what we can do over there, we can apply the root guard feature. And with the help of root guard feature, what happened? If you see right now, normally if you see the behavior, switch one, yes, yes. So right now, switch one is the root bridge, right? Can you see that? And switch two, let's go to switch two. I say that, hey, listen to me. I said, the spine tree, VLAN number one, priority will be 0. What happened? I said the priority 0. What happened? Now the switch two is saying, hey, what happened? Switch one is saying, hey, I'm receiving. Switch two is sending the superior BBD, and switch one is receiving. And they will change the port rows. Now the root port. Now what happened? Switch two will become the root bridge. See? And again, if I'm going to say that now, hey, now I'm not going to send the superior BBD, right? I'm not going to send the superior BBD. So in this case, what happened? Do so is fine free. Am I the root bridge? No. According to the switch two, he is the root bridge. And 100 is whom? 100 is the switch one. 100 is switch one. So to avoid this problem, what I can do on this particular interface, right? Interface is 0/0. This interface I'm talking about. Because I'm receiving the BPD on this particular interface. On this particular interface, I'm going to enable the spanning tree guard root. And now if you see, if this guy sends the superior video, what they will do? Immediately the switch one is going to put this interface into the root inconsistent state. Root guard is enabled and put this port into the blocking. Blocking in the sense of what? If you see so spine tree interface, E0/0 detail is called as a broken port, BKN. So spine tree is called as a BKN, broken. And now root inconsistency, because someone is trying to perform an attack, right? Someone is trying to say that, hey, I would like to become the root bridge. That's not possible. So if I'm going to enable the root guard feature over there, right? If I'm going to enable the root guard feature on the switch one, it doesn't matter who is sending the superior BBD. I'm not going to dictate that, hey, you will be the root bridge, because I'm the root bridge. I will be a centralized point. So in that case, what happened? I can save the huge amount of resources of my network as well as, right? Because the convergence will not happen. If the convergence will not happen, I can save the memory, CPU, and everything, right? All good. But if I'm going to see that right now, this is the switch one is still in the root inconsistent, which interface is 0/0. This interface. Because right now the switch two is keep sending the video, keep sending. Hey, I'm the root bridge. I would like to become the root bridge, not I am the root bridge. I would like to become the root bridge. Can you see that? Previously received the 103. Switch two was sending the 152. After 2 seconds, again he's sending. So he's keep sending, keep sending. Hey, I would like to become the root bridge. But what switch one is doing, on a switch one, we have enabled with the root guard features. He said, hey, you're not allowed to become the root bridge, right? Because I have a root guard enabled. But once this guy will stop sending the information, the superior BPDU now stop sending, right? What happened? Now this interface will move in the forwarding state. Root guard has removed, and now it will unblock this port automatically. You don't need to do anything, right? This is a root guard, guys, to protect my root bridge. All good?
So does this switch to is sending the superior BPDU, right?
Yeah.
Switch one
Yeah.
is not accepting, right?
No, switch one is not accepting. If you enable the root guard, then
So
he's
does
accepting. He's accepting, but he's not going to pretend that you will be the root bridge, because I have enabled with the root guard feature over there. No one can become the root bridge except me.
oh, does this interrupt traffic flow, sir? Any data flow?
Of course, this interface is the blocking state.
Oh, okay.
Now, MAC address 200, MAC address 100. Do you know on the single port we have a TX that is going to transmit the information, and when we have a RX on a single port, we have two types of ring. One is we have a TX, and one we have a mix. TX that is going to transmit, and RX that is going to receive it. Now take example. What happened? Take example. Right now, this is the DP port, right? And this is the RP port. Okay, this is the non-root bridge. What happened if the switch to stop receiving the BPD? If the switch to stop receiving the BPD, it could be any reason. The reason may be, I'll tell you the reason. What happened? Loss of BPD. Loss of BPD means what? Just because of the congestion of the link, I not able to receive the BPD because there is a congestion on the link. Maybe on the switch one, what happens? Some problem on the switch one side. They cannot transmit from the TX link. They cannot transmit any kind of BPD. So switch 2 will not accept it, right? Or maybe on a switch 2, the RX point, right? They have some problem. At any cost, right? If the switch 2 will not receive the BPD, loss of BPD, right? It could be any congestion will happen, loss of BPD. The TX, the switch 1 TX has some problem. Of course, this is the hardware, right? And maybe the switch 2 RX has some problem. TX means what I'm sending, RX means I'm receiving. So I can send it, right? I can send it because my TX is working fine, but my RX is not working fine. Then switch 2 will wait for the how many seconds? See, if you have a look on a switch 1 and switch 2. Let me remove this guy. Guys, I cannot make a congestion on this particular ring right now. Or, I cannot make a congestion. I cannot, create any kind of error in my TX and RX ring because these are pure hardware. What I can do, I'm going to enable the BPD filter feature, right? And what BPD filter is going to do, if you remember that in the CCNA part, right? The BPD filter is going to filter the BPD. Filter the BPD in the sense of what, right? It is not going to send the BPD. Not send, right? From the interface. So I'll just try to show you the problem right now. If you see on an interface on a switch one, I'm going to enable the BPTube filter on this particular interface. And let's go to switch one first. Switch two right now. Post name, switch two. Debug is fine tree events and debug is fine tree. Switch state. Switch one. Post name switch one. And interface is 0/0 spine tree. If you see right now, so spine tree interface is 0/0 detail. Received 2020, received 2021. I was receiving right now 2024. Let's do one. Go on switch one. I said that spine tree BPTube filter enable. I'm not going to send the any kind of BPTube now. Have a look. 230 is there. 230 is still there. I'm not receiving. And what happened? Still not receiving. What I'm doing over there, I make this RP port. Previously, this was the RP, right? DP. Now tell me, if you see right now, switch one, DP, switch two. DP. Is it possible on the same segment we have a 2 DP? No, loop will be there. Is it possible in the same span tree we have 2 row bridge? No, it's not possible. And this has happened just because of what? Loss of BPD, right? Because he's not sending the BPD. I just configure the span tree BPD filter over there that is going to filter the BPD. And because of that, what happened? Loss of the BPD is happening. System is not able to receive. System will converge this topology and say that hey, I'm the root bridge and he's also both our DPDP loop will be occurred. Of course, right? Understood? This is the problem. Understand this way, right? Take example of another topology we have. I can make like this. Switch one, system. Okay. So this the two links right now. Understand all this way. DP, 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 and block. Sorry, DP and RP. What happened if this guy stops sending the BPO, this particular link? So this guy also become the DP, right? And this guy also become DP. See, he's also root bridge and he's also root bridge. Loop is happening, right? Loop. Both link in forwarding state. Loop is happening. And just because of what? Loss of BPD. Maybe the TX is working fine. Maybe RX is not working fine. Maybe RX is working fine. TX is not working fine. Maybe the link has congested. Maybe switch one has an issue. They will not send the BPD. Maybe switch two has some issue. They not receive the BPD. It could be any reason, right? I'm just giving the one hypothetical scenario, right? And you know very well, and the first day of the lecture we have seen that the layer 2 loop is an infinite loop. Infinite. They will kill your switch. You don't have any other options. If the loop occur in the layer 2 network, you cannot stop that guy. Never. So better to use the solution. And what solution I'm going to use? I'm going to use the loop guard feature. And what loop guard feature is going to do? This guy is keep tracking the BPD. If the BPD is not received the interface, right? If the BPD is not received on interface, what happened? It will make that interface into the loop inconsistent state, called as a BKN, broken. If BPD is not received, if BPD is received is fine. It means that my Ethernet link and my switch 1 and switch 2, everything is working fine. If not, make it loop inconsistency. So have a look on our switch 1. What I can do right now, I'm just going to, there's one. So, sorry. So now, what I can do right now on switch 1, I'm just going to remove the BPD filter right now in front of you. Okay, leave it right. I'm not going to enable right now. And now they will change the role. Please come on. So RSTP is enabled, so they will change the role very fastly, right? All good now. This is the root code. Do just 90. So there is no loop. This is the root code. So according to the switch 2 as well as according to the switch 2, switch 1 is the root bridge. Here's the root bridge, switch 1. Right? Now let's go and switch 2. I'm going to enable the interface EGO/0 spine tree loop guard loop. And now use the spine tree interface E0/0 DT. Loop guard is enabled, right? Same way you can verify the root guard by putting the same command, do spine interface Ethan just as detail, and you can see that root guard will be enabled. I forget to show you. Now loop guard is enabled. Now he's going to keep tracking. So now if you see interface Ethernet 0/0, enable this guy. Now it will stop sending the BPD after enable BPD filter. So system will keep tracking. Now in second. 6 seconds, right? Remember the RSTP protocol. If the 3 BPD will be missed, right? It means 6 seconds. If the 3 BPD I will miss, I'm assuming that my neighbor is dead, right? Because in the RSTP protocol, the BPD is behave like a keep alive, right? So now what happened? I'm going to move this interface because I'm not able to receive the BPD. If I'm not receiving the BPD, my loop guard is enabled, and I'm going to put this port into the blocking state. Just to spine tree instance, sorry, detail, broken, loop inconsistent. Previously it was root inconsistent, now it's a loop inconsistent. And you are going to enable these features right now only on the blocking and RP port because both are receiving the BPD. Once I'm going to remove it now, if you see, once I'm going to remove it now, what happened? Now state will be automatically changed because now it will receive the video. If this guy will receive the video, nothing will happen, everything will be changed now. Do you suspect? And according to system, he's the root bridge. But still, my loop guard is still enabled. If something is happening, I will again see. Right now, loop guard is still enabled, right? But right now the port is root forwarding. But again, if this guy is not sending the any kind of video, if this guy is not going to send any kind of video, I will wait for the 6 second, right? That's a hold on time of the RST protocol, and loop guard is enabled. I'll put this port in the blocking state. But again, if this guy is going to not going to, it will start sending the BPD. What happened? Now it becomes in the normal. So that prevent the, you know, undesired loop. This is not desired loop. This is the undesired loop. Automatically, at any time will be created, right, in your network. And we know that, right? Layer 2 loop is very bad as compared to layer 3 because on the layer 3 we have a TTL, right? At the point, at the finite amount of time, the loop will be automatically break. But in the case of spanning tree protocol, we can say the layer 2, we don't have a concept of TTL, right? And if you don't have a concept of TTL, who is going to stop the packet? No one. So CPU will be high and maybe your device will be crash. Guys, any questions, anyone? I'm done with this finally now. Any questions you can ask me. Go through the book. Let me know if you have any doubts. I can tell everything. Otherwise, we'll start with the tomorrow. The topic will be either you can go for the DHCP. If it's up to you guys. Either you can go for the DHCP or either you can go for the Ether channel. Let me know which one you prefer. Let's make a Ether channel because some guys want to do the DHCP, so I'll call them so they can join from the Thursday, right? So we'll do the Ether channel tomorrow. It's fine.
Okay, sir.
Yeah. If you want a DSP, I can teach you. It's not a big deal. But some people are there. They want to join the DSP as well as. So I can call this guy in the batch so they can join it. So we'll do the Ether channel tomorrow, and then we have our DHCP on Thursday, and it will do the Friday as well as. So once we are done with the DHCP, then we'll do that. Till this weekend, I'll finish your switching batch. So once we are done with the DHCP on Friday, then we can make a HSRP and VRRP on Saturday and Sunday. I'll finish it before the Sunday, right? Switching.
No, what about proxy ARP and GR?
That comes in the proxy ARP comes in the routing part, bro. The static routing, and gratuitous ARP comes in the DHCP.
Okay.
See, the ARP concept is coming according to the syllabus by syllabus. Like I'll tell you, the DHCP you will get the concept of gratuitous ARP. You will get the concept of inverse ARP. You will get the concept of reverse ARP, right? Proxy ARP only comes in the routing part, right? Where you will get the concept.
Ah,
Okay, anything so you want guys from me to learn, I'll teach you. It's not a big deal for me. You just go through that and let me know if you want to read anything from me. I can teach you. That's not a big deal. All good, perfect, awesome.
Yes, sir. Sure.
Okay, guys, have a great night, everyone, and please keep reading the book. That helps you to see. I'll tell you one thing.